Voyager 1 is dying. Not in a dramatic explosion, not in a collision. It's dying the way a candle dies. Slowly, quietly, one flame at a time. Imagine this spacecraft the size of a small car, hurtling through absolute darkness at 61,000 kilometers per hour. No sun in sight, no planet nearby, no star for trillions of kilometers in any direction. It has been flying for almost 50 years, and right now, at this very moment, it is the farthest human-made object in existence. Over 25 billion kilometers from Earth. So far away that a radio signal, traveling at the speed of light, takes more than 23 hours just to reach it. In this video, we're going to trace the full arc of Voyager 1's journey, from the moment it launched to the day it finally goes silent, and then far, far beyond that, into a future so distant it makes human civilization look like a blink. The question isn't just how far Voyager 1 can go, it's what happens when no one is listening anymore. Let's start with what's keeping Voyager 1 alive, because it's not solar panels. At 25 billion kilometers from the Sun, solar energy is essentially zero. Instead, Voyager carries 3 radioisotope thermoelectric generators, or RTGs. These are small nuclear devices that convert the heat from decaying plutonium-238 into electricity. When Voyager launched in 1977, those generators produced about 470 watts, enough to power a few household light bulbs. That was all the energy Voyager ever had to run its computers, its heaters, its communication system, and its scientific instruments. Here's the catch. Plutonium-238 has a half-life of about 87.7 years. That means the fuel is slowly decaying, and with it, the power output drops. Every single year, Voyager loses roughly 4 watts. It doesn't sound like much, but over nearly 5 decades, that loss adds up to something devastating. Voyager now generates so little electricity that engineers have been forced to make agonizing choices about what to keep on and what to shut down. Think of it like a house where the power grid is failing. First, you turn off the lights in the rooms you don't use, then the heating, then the kitchen appliances. Eventually, you're sitting in one room with one lamp, knowing that soon, even that will go dark. That is exactly what's happening to Voyager 1 right now. When Voyager launched, it carried 11 scientific instruments, cameras, spectrometers, particle detectors, magnetometers. One by one, over the decades, they've been switched off. The cameras were shut down back in 1990, after Voyager took its famous pale blue dot photograph, that haunting image of Earth as a tiny speck suspended in a sunbeam. The software that controlled those cameras was deleted from the onboard computers. The ground computers that could interpret the images no longer exist. Even if you wanted to turn the cameras back on, you couldn't. By 2025, NASA engineers had shut down the cosmic ray subsystem, one of the instruments that originally helped confirm Voyager had crossed into interstellar space. In 2026, the low-energy charged particle instrument is scheduled to follow. That leaves just 2 functioning science instruments, the MAG magnetometer and the plasma wave subsystem. 2 instruments on a spacecraft 25 billion kilometers away. That's all that remains. And here's the part people overlook. It's not just the instruments. The heaters that keep Voyager's fuel lines from freezing are being turned off one by one. If the hydrazine propellant in Voyager's thrusters freezes, the spacecraft can no longer orient its antenna toward Earth. And if the antenna drifts off target, the signal is lost. Not temporarily, permanently. There is no rescue mission. There is no reboot. At 25 billion kilometers, you either maintain that razor-thin radio link or you lose the spacecraft forever. NASA engineers believe they can keep at least one science instrument running into the 2030s. The RTGs might provide enough power to transmit basic engineering data until around 2036. But these are optimistic estimates. After nearly 50 years in the most hostile environment imaginable, every day is borrowed time. A single unexpected failure, a frozen thruster line, a glitched computer, a degraded component, could end the mission overnight. So what has Voyager 1 actually accomplished in those 50 years? The answer is staggering. Voyager 1 flew past Jupiter in 1979, discovering active volcanoes on its moon Io, something no one had predicted. It reached Saturn in 1980, revealing intricate ring structures and providing our first detailed look at Titan's thick, hazy atmosphere. After Saturn, Voyager's trajectory flung it upward, out of the plane of the solar system, on a one-way path toward the stars. For the next 3 decades, it just kept going, farther than any probe before it, past the orbits of Uranus, Neptune, Pluto, and beyond the Kuiper Belt, into regions of space no instrument had ever measured. Then, in August 2012, something extraordinary happened. Voyager 1 crossed the heliopause, the boundary where the Sun's influence ends and interstellar space begins. But this wasn't a simple leap. First, it passed through the termination shock, where the solar wind suddenly slowed. Then came the heliosheath, a turbulent region where solar particles mixed with interstellar matter. Finally, the heliopause itself. Voyager 1 was the first human-made object to leave the solar bubble entirely. Its twin, Voyager 2, would later cross the heliopause in 2018, confirming what the first had discovered. For the first time in history, we had sensors in the space between the stars. And the data it sent back was surprising. The interstellar medium wasn't what many models had predicted. The magnetic field was stronger in some ways, the plasma density different from expectations. Voyager didn't just confirm theories, it challenged them. That's why every remaining watt of power matters. Every day, Voyager's instruments stay on. They collect data from a place no other spacecraft has ever been, or will be for decades to come. Now zoom out, because here's where the scale becomes almost impossible to grasp. Voyager 1 is currently about 165 times farther from the Sun than Earth is. In late 2026, it will reach a milestone that sounds almost poetic. It will be 1 light day from Earth. That means a command sent from NASA's Deep Space Network will take a full 24 hours to arrive, and another 24 hours for Voyager's response to travel back. A simple exchange, a greeting and a reply, takes 2 days, at the speed of light. And yet, despite all that distance, Voyager has barely scratched the surface of what lies ahead. The Oort cloud, a vast spherical shell of icy objects that marks the gravitational edge of our solar system, is estimated to begin somewhere around 1,000 to 2,000 astronomical units from the Sun. Voyager 1 is currently at about 165 astronomical units. At its current speed, it won't reach the inner boundary of the Oort cloud for another few hundred years. And the outer edge? That's roughly 100,000 astronomical units away. Voyager won't clear the Oort cloud for approximately 30,000 years. Let that sink in. 30,000 years just to leave our solar system's gravitational neighborhood. For context, 30,000 years ago, humans were painting on cave walls. We hadn't invented agriculture, we hadn't built a single city. That's the timescale we're talking about, and Voyager will still be nowhere near another star. But eventually, it will get there. In about 40,000 years, Voyager 1 will make its closest approach to a star called Gliese 445, a small red dwarf in the constellation Camelopardalis. Gliese 445 is currently about 17 light-years from Earth. But because stars are in constant motion, it will be much closer by then, roughly 3.5 light-years away. Voyager will pass within about 1.7 light-years of it. Think about that distance for a moment. 1.7 light-years. That's still over 16 trillion kilometers. Voyager won't enter Gliese 445's solar system. It won't orbit anything. It will simply drift past, a cold, silent piece of metal in the vast gulf between stars. And then it keeps going. Around 303,000 years from now, Voyager 1 is projected to pass within about 1 light-year of another star, TYC 3135-52-1. After that, the predictions become increasingly uncertain. Stellar motions are chaotic over millions of years. Gravitational tugs from passing stars and even massive interstellar gas clouds can subtly bend Voyager's trajectory, sending it on paths we can't fully predict. You might think that's the hardest part to accept. It isn't. The hardest part is this. Long before any of those stellar encounters happen, Voyager will be dead. Not destroyed, dead. Sometime in the 2030s, maybe a little later if engineers squeeze out every last watt, Voyager's power will drop below the threshold needed to operate anything. The transmitter will fall silent. The computers will shut down. The heaters will stop. The internal temperature will plunge toward the background temperature of interstellar space, just a few degrees above absolute zero. And then, Voyager will enter a new phase of its existence, one that will last incomprehensibly longer than anything that came before. Without power, without communication, without any functioning system, Voyager 1 will continue moving at 61,000 kilometers per hour. Nothing will slow it down. In the vacuum of interstellar space, there's essentially no friction, no drag, nothing to stop it. It will drift through the galaxy for millions of years, hundreds of millions, billions. Researchers have calculated that it could take on the order of 10 to the power of 20 years, that's 100 million trillion years, before Voyager would statistically collide with a star. A timescale so vast that even the stars themselves will have burned out long before it happens. Voyager will outlast the Sun. It will outlast every star currently shining in the Milky Way. It will outlast the Milky Way itself. Long after our galaxy merges with Andromeda, long after the last red dwarfs flicker and die, Voyager 1 will still be out there, drifting, silent, cold, carrying a golden record on its side. That record contains 115 images, greetings in 55 languages, 90 minutes of music, and the sounds of earth, wind, rain, birdsong, a mother's heartbeat. It was designed by a team led by Carl Sagan, assembled in the hope that someday, somewhere, something or someone might find it. The odds of that happening are vanishingly small. Interstellar space is unimaginably empty. Voyager could travel for longer than the current age of the universe without encountering anything at all. The golden record will almost certainly never be played by alien hands. But that was never really the point. The point was that we made it. That a species confined to one small planet looked up at the stars and decided to send a message. Not a weapon, not a warning, a greeting. Music and mathematics and images of who we are. Attached to a spacecraft that was only supposed to last 4 years, and instead lasted 50. Voyager 1 can't go on forever. Its instruments are fading. Its power is draining. Sometime soon, by cosmic standards, it will go quiet. But it will never stop moving. It will carry our voice into the galaxy long after there's no one left to speak. And perhaps that's the most extraordinary thing about Voyager 1. Not how far it's gone, but that it will keep going long after we're the ones who are gone. I hope you enjoyed the video. If you'd like to support the channel, a like or a subscribe truly helps. I'll see you next time.